Hello everyone. I would like to introduce the Nanobio Modeling Lab, Hiroaki Suzuki's lab, to prospective students. In my lab, we mainly handle and investigate biomolecules such as cells, DNA, and proteins using microdevices and microcomponents made with precise microfabrication techniques, and conduct research to create artificial cells. I would like to tell you a little bit about how I came to do this kind of research. When I was in junior high and high school, Formula One car racing was very popular. I had a vague interest in automobile mechanisms and fluid dynamics. In the university graduate school, I joined a laboratory specializing in fluid dynamics. One day, at a university open campus, I went to see a lab in the same department that specializes in micromachines. When I looked into the microscope displayed in the hallway, I saw an extremely small and sophisticated microstructure that was invisible to the naked eye. I was so impressed and became addicted in the field of micromachining and nanomicrotechnologies. I still love looking through a microscope and seeing things that are invisible to the naked eye. In my master's course, I conducted research on controlling jet flow using micro actuators. I was very happy that my results were accepted for an oral presentation at an international conference, so I went straight to the doctoral program. I felt great satisfaction in having my work directly recognized by the world. I was interested in the world and the United States, so I studied abroad at UCLA in California during my doctoral course. I joined a lab that was famous for its fluid dynamics, but the professor told me that he was going to move to biology. This led to a major change in the direction of my research, and I shifted to research on the fluid mixing in a microchip for biotech. Also, the colleagues I spent time with at this time are now professors and researchers at universities around the world. Even now when I go to conferences, I enjoy talking about old stories from those days with alumni. Now, since I myself have chosen a career path without deep consideration, I cannot tell my students like plan well for your future. Rather than that, I want you to find something that you can be more diligent about and immerse yourselves into. We live in an era where we often hear the words, cost performance, and time performance. But even though the performance improves by 10% or 20%, it will become more efficient only by a factor of 1.1 or 1.2 at most. If you find something that makes you feel, this is it, and immerse yourself in it, I think the results will be multiplied many times in the future. Now, returning to the introduction of the Nanobiomodeling Lab, I next talk about what you can learn here. First, you can learn microfabrication technologies. Microfabrication has stemmed from semiconductor manufacturing technologies, performed in clean rooms and yellow rooms. Mechanical structures in microscales are fabricated by techniques such as photolithography and etching, and you will be able to acquire the basics of these techniques. Our lab has equipment that can perform everything from CAD design to manufacturing, and I don't think there are many labs around that can perform all the processes in one lab. Recently, the semiconductor industry has been attracting a lot of attention, and some graduates have found employment in such industries. Next, you can learn about biology, mainly dealing with cells and molecules, rather than animals and plants. You will perform operations such as mixing small amounts of reagents with a pipette and allowing them to react. Students from mechanical engineering do not have this kind of experience, so you learn these operations in the lab training. We also use microscopes very often. Cells and molecules are small and transparent, so they are almost invisible as they are, so we use a variety of techniques to visualize them, such as phase contrast observation and fluorescence observation. In Japan, there are many manufacturers that are strong in analysis and diagnostics. Such companies are not just looking for chemistry or biology experts. When developing apparatus, we always need people who can design it, draw the drawings, and put it into production. I also think that having another specialty in addition to mechanics will be a great strength. Students in our lab also participates in many domestic and international conferences and present our research. Chuo University has a program that supports travel expenses for graduate students to attend conferences, giving them the opportunity to participate in international conferences. University research is directly connected to the world, and I hope you will experience the real pleasure of this in the lab. Your research results, along with your name, go out into the world at international conferences and research papers, and remain for future generations. This is the reason why I aim to become a researcher in the first place, and I hope that you too will aim to become world-class researchers and engineers. Finally, the Hiroaki Suzuki Lab operates as a one team, with the utmost importance being placed on the ability to interact and help each other with colleagues, to lead research and student life. Although each research topic is different, there are many parts that are related to each other, so it is important that we work together as a team. I believe that the most important mission of a university is to provide an environment in which students can do their best and devote themselves. I hope that you will take advantage of this environment, train yourself, and spread your wings in society and the world. Thank you for watching. I am looking forward to working with you in the Nanobio Modeling Lab.